Welcome back to The Explainer. I am absolutely thrilled to have you here today because we are going on a bit of an archaeological dig. Now, we aren't looking for ancient artifacts or buried treasure. No, we are excavating the hidden clues buried deep within the Cambridge Computer Science past papers. Let's just dive right into this because time is of the essence. Whether you are building your foundations in the core IGCSE syllabus codes, 0417, 0478, 0983, 0984, or 2210, or you are stepping up to face the ultimate beast, the 9618 AS and A-level paper, there is one specific concept that constantly, and I mean constantly, trips students up. I'm talking about mastering the case structure for multiple selection. You'd be amazed. Most students leave completely easy, totally avoidable marks on the table when they encounter this specific question type. They read the prompt, they freeze, they panic, or they just write these massive paragraphs that completely miss the mark. But don't worry. By the end of this explainer, you are going to understand exactly how the examiner's mind works. We are going to peel it back layer by layer until we reveal the absolute perfect full-mark answer.
So, the million-dollar question, why do so many fail at multiple selection? Well, to understand that, I want you to meet two sample students, Alex and Sam. Now, Alex is our classic overthinker. We've all been there, right? When asked about a multiple selection scenario, Alex goes into full panic mode and just overloads the answer with raw computer science facts, literally dumping every single thing they've ever memorized about variables, data types, and syntax onto the exam page. But here's the catch. Alex provides absolutely zero analysis. On the other side of the room, we have Sam. Sam is just racing against the clock. Sweat on the brow, rushing past the crucial command words in the prompt, entirely missing what the question is actually asking for, and just scribbling down a generic copy-pasted code snippet. If we look at the red pen marks on their actual exam papers, both of them lose easy marks. Why? Simply because they failed to uncover what the examiner was actually digging for. They missed the entire core objective of the question.
All right, here is our roadmap for today's explainer. First up, we're looking at the challenge. Second, the strategy reveal. Third, we'll go through the transformation. Fourth, we'll jump into a quick interactive workshop. And finally, we will lock in the final system. Let's keep moving.
Act 1. The challenge. Decoding the case structure.
Okay, so the absolute most crucial point here is understanding the theoretical architecture of what we are actually dealing with. A case structure is not just some random piece of syntax you memorize from a textbook. It's a highly efficient control structure used for multiple selection. In plain terms, it evaluates the value of a single variable and then executes specific, targeted code blocks based on that exact value. But here's the real mystery. Why do students find applying this seemingly simple concept to unfamiliar contexts so incredibly difficult? Well, it's because the academic benchmarks set by Cambridge require logical, structured reasoning. The assessment framework explicitly prioritizes analytical depth over superficial breadth. Listen, examiners do not just want to see that you can write case of on a piece of paper. Anyone can do that. They want to see that you understand the underlying causal relationships. They want to see integration with other syllabus areas. The principal examiner reports, which are basically the examiner's secret playbook, consistently highlight the candidates who reference cross-topic connections achieve significantly higher marks. For example, explaining how a case structure impacts memory allocation or processing speed compared to a giant messy block of nested if statements. That is what gets you the A-star. It is all about depth, not just dumping code.
Act 2. The strategy reveal. Assessment objectives and frameworks.
Take a really close look at the difference between an average student and a top-tier student on this slide. On the left, we have superficial breadth. This is Alex's flawed approach we talked about earlier. It is literally just listing raw facts and isolated code snippets. It shows the examiner you have memorized a textbook, sure, but it absolutely doesn't show you know how to solve a complex computational problem. On the right, we have analytical depth. This is where the magic happens. This is where you demonstrate logical, structured reasoning. You link your technical choices to cross-topic connections. When the exam command word says evaluate or discuss, they are begging you for this exact level of depth. They want you to justify why this specific algorithm is the best possible choice for this specific scenario. Oh, and hey, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get back to the framework.
So the logical next question is, how do we actually structure this analytical depth on the page? Enter the PEEL framework. If you don't know this, write it down right now. Step 1, point. You make your initial statement clearly and directly addressing the specific command word in the prompt. Step 2, evidence. You provide a highly specific example or a targeted code snippet derived from the case structure. Step 3, explanation. You break down exactly how this code functions within the larger system. You explain the why. And finally, step 4, link. This is the absolute most important part, guys. You link your explanation directly back to the context of the question. When you successfully align this Peel framework with Cambridge's specific assessment objectives, you instantly start to uncover those hidden clues in the exam question. You stop writing fluffy, generic answers, and you start writing precisely what the grading rubric demands.
Act 3. The Transformation. Procedural Framework Application.
Let's move on and see how this all builds into real, practical application under exam conditions. We are talking about the procedural framework. Algorithmic thinking when it comes to case structures requires a very systematic, step-by-step decomposition. First, you design algorithms. This means you select the appropriate data structures before you even write a line of code. Second, you implement solutions. You write clean, efficient, well-structured code. Third, you test thoroughly. And fourth, you evaluate performance. Now, this brings us to a massive, massive secret that so many students don't realize: the method mark strategy. In Cambridge computer science exams, marks are heavily awarded for the correct process, even if your final output has a tiny syntax error. If an examiner sees you logically designing the algorithm, correctly setting up the logic of a case structure, and attempting to handle the input systematically, those red pen marks transform into green check marks. You literally get marks for the method. If you just try to guess the final answer without showing your computational decomposition, you get nothing. 0.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Seriously, consider this your ultimate wake-up call. When you see these complex algorithmic questions in your paper, an alarm bell should be ringing in your head. It is time to stop randomly guessing and start applying a highly structured method. Let's look at exactly how to execute that.
Act 4. Interactive Workshop. Critical Analysis Under Pressure. Get ready to actually apply this.
Okay, it is time to put you to the test. Let's look at this evaluation metric table on the screen. Higher order assessment objectives, the ones that get you the top grades, demand that you evaluate alternatives and compare computational approaches. Look at the 3 metrics here: time complexity, space complexity, and edge cases. I am putting 60 seconds on the virtual clock in your mind right now. I want you to think back to Sam's rushed answer from earlier. Remember? Sam just threw down a basic case structure without thinking it through. Where exactly did Sam lose the marks? Look really closely at the table. Got it? It's the edge cases. Sam's rushed, sloppy algorithm might work perfectly for standard expected inputs, but what happens at the boundary conditions? What if the user inputs an unexpected special character or a negative number? Sam's code completely crashes. Evaluating algorithm quality requires identifying these exact metrics and their direct effect on performance. If you aren't discussing edge cases when evaluating a case structure, you are literally leaving major marks behind. Now, for our 30-second speed writing challenge. Let's look at the deconstruct, solve, evaluate cycle. Step 1. Identify given information. Step 2. Break it into logical steps. Step 3. Solve systematically. Step 4. Check for reasonableness. Step 5. Make justified recommendations. Imagine you only have 30 seconds to draft a perfect PEL paragraph evaluating a case structure. How do you do it? You deconstruct the question immediately to extract the relevant data variables. You solve it by selecting the correct analytical framework and executing it with incredibly clear pseudocode or program code notation. Then you evaluate it by checking if your solution is actually reasonable and making justified recommendations using the correct Cambridge terminology. This specific cycle is your absolute lifeline when you are under the immense pressure of the exam room. It forces your brain to be analytical, not just descriptive.
Act 5. The final system. High-stakes examiner alerts. We're at the climax here.
We have dug deep, and now we have finally hit the mother lode. These points on the screen are the high-stakes warnings pulled directly from the Cambridge Principal Examiner reports. These are the top 3 fatal mistakes that students make year after year. Number 1, using the wrong formula or algorithm for the wrong context. Number 2, forgetting to check boundary conditions in edge cases. And number 3, providing generic answers that are not specific to the question context. To make sure you never ever forget this, let's use a quick memory hack. I want you to think of the acronym CASE. C stands for context. Always apply it. A stands for algorithms, pick the absolute right one for the job. S stands for sequence, break your logic into clear steps. And E stands for edge cases, always check your boundaries. Just remember CASE to perfect your case structures.
Look, if you take absolutely nothing else away from this entire explainer today, you need to remember this exact quote direct from the examiner alert. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. I literally cannot stress this enough. Let's say the exam question is about a factory automation system. Your case structure, variables, and your Peel paragraph explanations absolutely must talk about the specific sensors, the conveyor belts, and the factory safety protocols mentioned in the prompt. If you just write about abstract variables like X and Y or input A, the examiner is going to cross it out and you will lose the marks. Context is king. You must link every single analytical point back to the specific real-world scenario provided in your exam booklet.
So here it is. This is your ultimate computer science success blueprint. 3 undeniable rules that guarantee top marks if you follow them. Rule 1, command word decoding. Never start writing your code or your paragraph until you know exactly what the examiner is asking. Are they asking you to state? Are they asking you to describe? Or are they asking you to evaluate? They all require entirely different answers. Rule 2, Peel framework application. Structure every single long-form written answer with point, evidence, explanation, and a highly contextual link. Rule 3, time management matrix. Use that deconstruct, solve, evaluate cycle we just talked about to systematically tackle complex algorithms without wasting your precious time. If you follow this blueprint and you consistently address those cross-topic connections, you will be virtually unstoppable on exam day.
And honestly, the proof is right there in the results. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. You can't just watch this once and expect to be a master. You actually need to apply these frameworks to your own past paper practice until it becomes complete second nature to you.
The clock is always ticking in that exam hall. Every single minute you spend staring at a blank page, trying to remember syntax, is a minute completely wasted. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. We've reached the end of our dig today and we've successfully uncovered the blueprint. But remember, a case structure isn't just some exam trick to get an A star. It is the exact same foundational logic used to route millions of data packets across the internet every single second. So the next time you sit down to write a line of code, ask yourself, are you just reacting to inputs like a robot, or are you actually engineering the optimal path forward? Keep practicing your past papers, and I'll see you in the next explainer.